Hey, today I thought I would look at pleasure with profit, consisting of recreations of diverse kinds. So, this is one of those fascinating books, sort of an activity book. So, we've got numerical, geometrical, mechanical, statical, astronomical, horometrical, cryptographical, magnetical, automatical, chemical, and historical, published to recreate ingenious spirits, and to induce them to make further scrutiny into these and the like sublime sciences, and to divert them from following such vices to which youth in this age are so much inclined, which kind of tells me that it's always been a certain way with older people, being worried about younger people, as many know. All right, to the ingenious readers, and principally to such as are mathematically inclined, recreation. I love the drop cap, by the way. This book actually has very cool graphical elements all through it, if I recall correctly. Recreation, saith a late learned divine, is a second creation. When weariness hath almost annihilated our spirits, it is the breathing of the soul, which would otherwise be stifled with continual business. And this interval of rest or recreation produceth the same effect, as well in sensitives, vegetives, wow, as it doth in man, according to that of the scholast. I don't remember when this book's actually from. 1694. So, although some corporeal exercises may to some bodies tend more to health, and some mental labors more to wealth, yet none affords the mind more pleasure with less repentance than those of mathematics do. Oh, goodness. Swimming. Swimming hath saved many a man's life. All right, that's a long preface. Okay, what do we have? Of digit, article, mixed, square, and cube numbers. So that's geometrical recreations. Mechanical, so like building stuff. Statical recreations, that's referring to statics. So kind of balancing tricks is what that often is. Astronomical recreations, astronomy. Cryptographical recreations, horometrical recreations. Arts and science, mathematical, professed and taught by the author. It says advertisement, but it's really an advertisement. The place of the author's residence is about 10 miles from London westward at a place called Southall, not actually English. Might be getting that wrong. In the road between Acton and Uxbridge, and 3 miles from Brainford. Honestly, that's enough information to find where the author used to live, assuming Southall is not in the same place anymore. where he intends to read the mathematics and instruct young gentlemen and others, and to board upon reasonable terms all such as shall be pleased to make a more close application to those studies where such boarders and others during their time of residence with him shall have the use of all books, maps, globes, and other mathematical instruments as are necessary for their instruction till they provide themselves of such as they shall have occasion for afterwards. Interesting that maps he sees as a mathematical tool, but they are. Okay, numerical recreations. If you would multiply any number by 5, add a cipher to the given number, then the half of that number will be equal to your product. In other words, multiply by 10, then divide by 2. It's funny, I've seen people really criticize this idea of add a cipher to the number using that language in math education because they feel it confuses students. How are you going to multiply a number by 10 by adding 0 to it? Like, they're afraid that kids will get mixed up between literally adding 0 to the number, like 6 plus 0 is really 6, but adding a 0 to a 6 in the written form of the 6, then a 0 makes 60, and that's what people mean. So clearly that goes back a long way. Sort of thing. Ooh, the number 6 hath another eminent property. All its aliquot parts are equal to himself, as his half, which is 3, his third, which is 2, and his sixth, which is 1, being added together do make 6. His half, they have anthropomorphized the number 6. So we would call that a perfect number today. And of numbers that have this property, there are but 10 to be found between 1 and 1 million of millions, which are these exhibited in this following scheme, and in these numbers you may observe an order for every of the odd places, as the 1, 3, 5, 7, and 9 do terminate in 6, whose half is 3, an odd number, and the even places, namely the 2, 4, 6, and 8, do terminate in 8, the half whereof is 4, an even number. If you would multiply any number by 7, add a cipher to the given number, and take the half thereof, to which half add the double of the number given. The sum of them shall be the product of the given number multiplied by 7. I would have to work out why that is true. I have to sit down and do it. Observation. This digit 9 hath a privilege above all the other digits. For if you take any number, the 9's taken out of the gross sum of that number, or of all the parts thereof, severally the remaining digit will be still the same. Example. In the number 36 there are 4 9's contained therein, and so if you multiply 9 by 4, it will produce 36, and if you take the 9's out of 36, they are 4 also. In like manner, if you take the 9's out of this number 248, it is all 1, as if you should take the 9's out of the simple figures 2, 4, and 8, which do make 14, from which 9 being taken, there will remain the digit 5, and also if you divide 248 by 9, the quotient will be 27, which shows that there are 27 times 9 in 248 and a digit 5 remaining. Okay, so that's a cool trick, actually. I'm not sure I knew that exact trick. All right. Let's find something else here. A table of the 9 digits, each of them being multiplied into all the 9 digits and the several products of those multiplications added. Okay. Of the digit 1. Little can be said concerning this digit, for that it neither multiplieth nor divideth, but leaveth the number which is multiplied or divided still the same. But this you may take notice of, that any two terms taken equidistant from the middle term do make 10, and the middle term, which is 5, doubled, does make 10 also. Comparative arithmetic, or the relation of numbers in quantity. Of arithmetical, geometrical, and musical properties. Of course, historically, music was taught alongside arithmetic and geometry in the basic education system. Oh goodness. Geometrical progression. So it's a series. It's multiplying by 2 every time. This one's times 3, times 4, 5, 6, 7, 8, 9, 10, 100. I love the triangles, very aesthetic. Numerical. Concerning the rule of 3, or golden rule, both single and compound. This rule may, and most properly, be called the rule of proportion, for that it teacheth in any case, by having 3 numbers given, to find a fourth which shall be in proportion to them, and for the reason of the manner of working this rule, the theorems delivered in the foregoing chapter will be subservient. When 3 numbers are given and a fourth is demanded, the second bears the same proportion to the third as the second bears to the first. Following example. The product of the first and fourth is equal to the product of second and third. That's actually a nice thing to know. Ooh, let's look at them. Geometrical progressions. Where were they? Those triangles. Oh, here we are. Okay, well, yeah, I mean, that makes sense. 2 times 4 is the same as 1 times 8. Yeah. That's interesting in its way. Interesting. Of the increase of swine, corn, sheep, etc. So it's a geometric series, as it were. That's a lot of pigs. What quantity of corn will be capable of receiving 1 grain of corn and the increase of it for 8 years? And to what number of grains will the increase of that 1 grain arise unto? Sort of using concrete examples to make it seem, woe of men. He's using concrete examples to make it seem more relatable. It may seem hard to conceive that from 8 persons which were saved after the deluge or Noah's flood should spring such a world of people to begin. A monarchy under Nimrod being but 200 years after the flood, and that amongst them should be raised an army consisting of 200,000 fighting men. But it is easily proved. For if we take but one of the children of Noah and suppose that a new generation of people began at every 30 years, and that it be continued to the 7th generation, which is 210 years, for then of one only family there would be produced 111,305, that is, 111,305 souls to begin the world, although in that time men lived longer and were more capable of generation, multiplication, and increase. Now, such a number arising only from a simple production of only 1 yearly would be far greater if one man should have many wives, as in ancient times they had. And from hence it is also that the children of Israel who came into Egypt, only 70 souls, yet after 210 years' captivity, they came forth with their hosts, so that there was told 600,000 fighting men, besides old people, women, and children. And he that shall separate but one of the families of Joseph, it would be sufficient to make up that number, and how much more would it be then, if many families were joined together? So that's all music theory. Of arithmetical verifying. Of numerical, enigmatical problems. Okay, so it's a simple algebra problem, but he appears not to be using the modern type of notation. If 136 pound be to be divided between 2 persons so that one must have 18 pound more than the other, how much must each person have? From the given sum, subtract 18, the overplus that one person must have above the other, and the remainder will be 118, the half whereof is 59, and so much must the one person have. It makes sense. That's a perfectly sensible way to do it. And if you add 18 to 59, the sum will be 77, and so much must the other person have. For these two numbers, 77 and 59, added together do make up the whole sum of 136 pound. I actually wonder why he's putting the numbers in parentheses like that, maybe to make them stand out. So that's cool. There were 5 bags of money, and in the biggest bag there were as many more pounds as there was in the least, and in the middle bag there was half as much as there was in the biggest and least together. And each bag from the least had in it 30 pound more than the other. What number of pounds was in each bag? So then he's working it out. Again, without modern type of notation. Let's see, what else? Oh, okay, a cistern problem. This is like one of those work problems that you sometimes see. These were certainly taught well into my lifetime. I remember solving these in school. I don't know if they're still done. The focus on math education is different now. There is a cistern which hath 4 cocks of different sizes. Okay, let's hold up for a second in case you wonder what this is all about. That's like a tap. It's basically, think a faucet coming off of it. In this case, cock is short for something else, and I honestly can't quite remember what it is. Which cistern holds 8 barrels of water? Why is there a question mark? If the first or least cock be opened, the water will be 6 hours in running out. If the second cock be only opened, the water will issue out in 4 hours. If the third be only opened, it will run out in 3 hours. And if the fourth and biggest be only opened, it will run out in 2 hours. In what time will it run out if all the 4 cocks be set running together? So if I'm reading this right, he's going to use the same technique that's still taught. Okay, so if the least cock will vent 8 barrels, that is all the water, in 6 hours, the second would vent 12 barrels in that time, the third 16, and the fourth 24, in all 60 barrels. Oh, okay. Here is now a proportion between 60 barrels and 8 barrels, and between 6 hours and the time that all the water will be vented in, if all the cocks were opened. Wherefore say, if 60 barrels will run out in 6 hours, in what time will 8 barrels run out? So we have this proportion. Multiply 6 by 8, the product is 48, which should be divided by 60, but being it is less, the quotient will be 48/60th parts of an hour, or 48 minutes, and in such time will all the water run out if all the 4 cocks be set open. Again, that's one that I would want to write down somewhat to follow a little better. Oh, goodness. Of numbers thought upon. A plain and easy method of extracting the square root of any number, how great soever, without the help of multiplication or division. Okay. How to make a tarifa for one or more figures, that is, for any digit or mixed number. Interesting. Table. A brief and compendious way of multiplication, wherein the product is given at once without several workings or writing down any other figures but the product itself. Yes, do let us find out. Example, let it be required to multiply 7,432 by 45. All right. Multiply as the line directs you. Say 5 times 2 is 10, place 0 under unities and carry 1 in mind. Say 5 times 3 is 15 and 4 times 2 is 8, which added together with 1 in mind makes 24. Set down 4 in the next place on the left hand and carry 2 in mind. I have literally never seen this algorithm before in my life. Say 5 times 4 is 20 and 4 times 3 is 12, which added together with 2 in mind makes 34. Place the odd 4 in the next place and carry 3 in mind. Say 5 times 7 is 35 and 4 times 4 is 16. Which added together with 3 in mind makes 54. Set down 4 in the next place and carry 5 in mind. Lastly, say 4 times 7 is 28 and 3 in mind is 33, which set down and the work is at an end, and the product of 7,452 multiplied by 45 is 344,440, as in the margent. The margent. Okay, and the next 3-digit numbers. That is a weird algorithm. I may have to go back and... That would actually be interesting to work out how that algorithm behaves. Let's see. All sort of fun stuff in here. Numerical devices. So, that is the numerical recreations part. I think I made